Hi, in this video we'll see simple proofs with the simplification rule. Hi, this is Logic Self-Taught with Dr. Phi. In this video we'll take a look at some proofs with the simplification rule. You can see the arguments that we will show to be valid. It's actually a good idea for you to try to do those proofs. If you have problems, watch on. Let's recall what the simplification rule allows us to do. It tells us that if we have a conjunction, we can derive either the first or the second conjunct. We will also use the rule of conjunction. Given two propositions on their own lines, we can infer their conjunction, and the order in which the conjuncts are conjoined doesn't matter. We can use it either way. We will use these two rules in our proofs. And it bears emphasizing that the rules actually allow us to do the opposite. The conjunction rule allows us to build more and more complex conjunctions, and you've already mastered that skill. The simplification rule goes the other way, as it were. It allows us to decompose conjunctions, right? We will also have to do it step by step. How do we proceed? Well, we proceed the way that we've proceeded so far. We basically have to think about how to get the conclusion. We need a conjunction. We will basically have to construct it by means of conjunction, which means that we will need both conjuncts, here B and C. So now our task is to get B and C from the premises somehow. And if you look carefully, you'll see that B is the second conjunct of premise 1, so we'll be able to apply simplification to get it. And C is the first conjunct in line 2, so we'll be able to apply simplification to obtain C. We are ready to go. Our first move, get B by simplification. Our second move, get C by simplification. This time we apply simplification to line 2. Well, these are the ingredients that we wanted to derive the conclusion. We can now conjoin them and get what we wanted. This is a very simple proof. We got what we wanted, so we are done. Let's take a look at a slightly more complex proof, and we essentially proceed in the very same way. We need to figure out how to get our conclusion. It's a conjunction, so we'll need to have the first conjunct, C and D, and the second conjunct. So let's think a little bit how we could get both. Well, let's start with C and D. If you look at the premises, you'll see that C and D, the whole conjunction, is the first conjunct of the proposition in line 2. So we can basically apply simplification to get it. Sometimes instead of planning further, it's actually useful to carry out this step immediately. So let's just do it. Let's apply simplification to line 2. Now let's look at B. We can find B buried in premise 1. It's a conjunct, right? But we shouldn't be tempted to apply simplification to line 1. That would be a problem because, remember, inference rules don't apply to proposition components. Clearly, there is a strategy of deriving B. We can derive the second conjunct, B and D, from line 1, and then we will be able to derive B from thus derived conjunction. We have what we wanted. We have the ingredients that we needed to apply conjunction to obtain our conclusion. Our first ingredient, the future first conjunct, is in line 3. The second is in line 5. We apply conjunction, embracing the first conjunct in parentheses because it's complex, and we got what we wanted. Okay, this is part of a proof that would show that conjunction is associative. We proceed in just the same way. We take our notebook, we analyze what we need. We need a conjunction whose first conjunct is A and B, second conjunct is C. Well, in this case, we don't have A and B, so we basically will have to get A on its own and B on its own. Well, if you look carefully, you'll see that A is a conjunct in premise 1, so we'll be able to get it by simplification quite easily. Now, to get B, we will have to apply simplification to line 1 again to get the conjunction B and C. And now, to get B on the one hand and C on the other, we again apply simplification this time to line 3. It's worth pausing at this point. This is basically what simplification allows us to do. If we have very complex conjunctions, we can simplify them down to the ingredients. We will not always need to go so far, but here we indeed don't need any ready-made conjunctions. We need the ingredients so that we can build the further conjunctions from them. So now the conjunction that we need is our A and B, and we do have ingredients for it in lines 2 and 4. So we apply conjunction, watching the order. And now the final step. To obtain the conclusion, we need the conjunction A and B, which we have in line 6, and C in line 5. So we've finished the proof. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.